All right, folks. Well, welcome back. Let's pick up with where we left off with yesterday, and I want to go ahead and I want to finish up with the discussion of conversions today, and that way when we can go ahead and get back to the discussion of the kinematics. Just a quick note, quick administrative note before we continue on. Um, I want to see how well you guys are doing with the work here. And that way, then I get a little bit of feedback. I haven't really seen anyone since we met last. And so, based on the work that you've turned in with Zoom and with the lectures here, looks like you guys are getting it. But again, I'm doing the work for you as well. So, and the homework looks pretty good for the most part. Um, However, like I said, I want to kind of get an idea of how well you guys are understanding this. So, what I've done then is I've arranged a time next week. So, right now it looks like it'll be on Wednesday. Next week where we will meet, and I'm just going to give you a quick quiz, mini exam quiz. So let's do this. So today's Thursday. Let me do this to give you a week's notice. Then next Thursday. So I'll go ahead and reschedule that. Next Thursday, then we'll meet. Quick exam, mini exam quiz, just on the material we've learned so far. So there will be conversions on it. There will be discussion. There will be questions about interpreting graphs, position time graphs, velocity time graphs, calculating for velocities, calculating for displacements. And so we will. What we'll do is next Wednesday then. We'll have a little Zoom. We'll have a Zoom meeting to review. So next Wednesday we'll review on for the mini exam quiz type that you'll take next Thursday. And at that point, then I will explain for you the procedures that we will use in order to get that done. And so again, just to kind of give me the opportunity to see how well you guys are doing, and hopefully I get a chance to see you as well. Okay, so next Wednesday, so I'm going to reschedule things a little bit. Next Wednesday, we will meet for a Zoom meeting. We'll meet live during our class time. I'll take review questions, but I'll also go over with you the procedures that we'll use for the exam that we will take on Thursday. Okay, so let's go ahead then and make sure then you come by and you see me, get the questions answered. Okay, get your questions answered, and hopefully you'll do fine. Okay. All right, let's go ahead then, folks, and let's pick up with where we left off with yesterday. Okay, and so with these conversions, then it's a pretty basic process. You have to practice it a little bit. For those of you who haven't done it before, it takes a little while. It takes a few times to kind of figure out the process by which you do these conversions. But once you get it done, the process is very redundant. You can use the same process over and over again, and you will be able to get the conversions done. And so what does the process entail? It entails you basically asking yourself 3 questions and answering those 3 questions. Okay. The first question then being, what is the quantity? What do you start out with? That is, what is given to you in the problem? What is the measurement that's given to you in the problem? Then the second question is, what do you need to convert that into? What is the quantity that you want to achieve at the end of the conversion? Okay. And then finally, what are the conversion factors that you need in order to get that done? Now, I would suggest early on that you list everything, make sure you have it right in front of you, and then go ahead and work that in. Okay, so let's take a look at this problem here. We left off with this problem here on yesterday, and I asked you to work this out. Okay, so if you need to, pause the video, go get your work, and let's compare answers here. Okay, so go ahead and pause the video, get your work, and then come on back and let's compare answers. Okay, all right. So let's take a look at what we have here. This is the quantity that we were given. So how do you know that this is the measurement, this quantity that we're given? Well, remember, all measurements have to have a number and a unit. Okay, so here's our number. Here's the unit here. It is in units of volume per minute. So volume per time. So this is a rate. And they want us to convert that into this unit here, which is microliters per second. Okay, so let's go ahead and let's write out the conversion. Okay, the conversion then is going to be one long fractional problem where you're going to multiply fractions together. That's essentially how you want to view conversions here. Okay, so you have to identify the starting fraction. That's the measurement that you start out with. the end fraction, that's the measurement that you want to end up with, and then the conversion factors, which are fractions. Remember, ratios are fractions, so the fractions that you need to get from start to finish. Okay, so here, the first one here, the first fraction then is going to be 0.44. This is a unit ratio, so it's going to be milliliters over 1 minute. So that is the first fraction. We want to convert that into microliters, okay, per 1 second. So we start out with the unit ratio, we want to end up with the unit ratio, okay? So we know what the value is and the measurement is down here. We just need to figure out what number goes on in the numerator there. Okay, so we have that. Let's list the conversion factors that we need. Okay, so we have two different conversions we're doing here. We're converting from milliliters to microliters. We're converting the volume unit, and then we're converting between minutes and seconds. That's the time unit. So let's go ahead and list that first. And so what do we list here? We list then what the relationship is, what is the equivalence between those two units that we know of, that is accepted and defined. Okay, so we know then that it is accepted that there's 60 seconds for every 1 minute. We know that. How we're going to use that, we'll talk about that in just a moment. Okay, all right. So that's pretty straightforward. It allows us to, this particular equivalence here includes the minute and the second unit as well. Okay, all right. So let's go ahead, and that takes care of the conversion on the bottom. But what about the conversion on the top? Well, we have to convert between milliliters and microliters. Now, I don't know of anyone, and there may be people out there, but I don't know them. Okay, but I don't know of anyone who can remember what the relationship is between milliliters and microliters directly. So most of us humans have to go between, there has to be a relationship that we have to take advantage of that sits between milliliters and microliters. And so we know this, that there are 1,000 milliliters in every 1 liter. So we know that the base unit here is liters, so the prefix milli represents 1,000. So you have 1,000 of these milliliters in 1 liter. Okay, but folks, that doesn't get us to microliters. So we need to remember or look it up what the relationship is between microliters and liters, because the base unit here, there it is. We have the base unit. We just need to remember what this prefix is. The prefix micro represents a million, so that's going to be 10 to the 6th microliters for every 1 liter. Okay, and so those are the conversion factors. Those are the relationships that we need to get our conversion factors that we will use to get this conversion done. The question is, do we need any more? Well, to answer that question, we just have to ask ourselves this. In these three here, between these three equivalences here, do we have all of the units accounted for in our conversion problem? Well, we do. Well, we start out with milliliters here. Well, there's milliliters right here. Okay? We have minutes here. There's minutes right there. We have microliters here. There is microliters here. And then we have seconds, and there's seconds here. The unit liter then must just cancel out, and we'll figure that out in just a moment. Okay. All right. So with that said, we have what we start out with. We've answered the first question. We've answered the second question. This is what we want to end up with, and we've answered the third question. Those are the conversion factors. Those are the values that we will need to make our conversion factors. Finally, then, it's just a matter of plugging in our values. Okay, plugging in these here. So which one of these three will we use first? Well, it depends on you. Should we convert the time units first, or should we convert the volume units? Well, let's do the time unit. That's going to be the easier one first. Okay, so let's go ahead and use this one. So how do we plug this in as a fraction? And the goal then, remember, is to get minutes to cancel out and end up with seconds in the denominator. Well, if you take a look at this here, if we have 1 minute in the numerator, and we have 60 seconds in the denominator. That means we take this, and we place it so that minutes is on top, seconds is on the bottom. Why do we do that? Because there's the minute unit on the top. That'll cancel out this minute unit on the bottom. There it is. And now we have seconds on the bottom on both sides of that arrow. That means then we are done with this conversion factor right here. Don't use it again. And we've plugged it in the correct way. Okay, so that's how you're going to go about doing this. Okay, so with that said, then we've taken care of the time unit. Let's go ahead and let's take care of the volume unit. Okay? So we start out with milliliters here. We start out with milliliters. So I hope then that you recognize that what we will use next is this one right here, because this relationship has milliliters in it. And so the question now is, how will we plug it in? And how will we plug it in here? Well, hopefully at this point you are starting to catch on. You'll see then that we're going to plug in liters on the top and 1,000 milliliters on the bottom. Why? Because that allows us to cancel out that unit there. Okay. All right. So we now have used this conversion. We've used that one. Don't reuse it. So understand this. Once we've used up one of these equivalences here, we're done with it. Don't reuse it. So I physically sometimes just cross it out to remind myself to not use it. Okay. All right. So with that said, now we're not quite done yet. Why? Because remember, we want to end up with microliters here. This is liters. So we have to go ahead and use the final conversion factor, final equivalence here. Okay. And hopefully you recognize that we'll plug it in as 10 to the 6 microliters on the top and 1 liter on the bottom. Why? Because it allows us to cancel out that unit right there. Okay, so now the last check that we need to do to make sure that we've done everything correctly, that we've plugged all of these values in correctly, is we want to make sure then that we check for the units. Okay, all right, so we've used that one already. Okay, let's check for the units. Okay, we start out with milliliters here. We want to end up with microliters. On the way then, do we end up with microliters on both sides? Well, there's microliters in the denominator there, and that's where we want it in the end. That's good. Okay. We start out with minutes here. We want to end up with seconds on the right-hand side here. So we got minutes out of the way. So we have seconds on the left-hand side here. We have seconds on the bottom here. We have seconds in the correct place on both sides of the arrow. Again, we plugged everything in correctly. Okay. Which means that at this point, folks, once you have the unit analysis done, plug the numbers into your calculator, and then you get your final answer. Okay. So let's go ahead then and let's plug that in. And hopefully, if you get your answer, if you did this, if you plugged it in correctly into your calculator, this number ends up being 7. Oh, sorry. This number ends up being 7.3 microliters per second. And that's the new rate that we have there. Okay. All right. Very good, folks. So let's go ahead and make sure you compare that with your answer. Okay. I want to do one problem from the homework that tonight. And so if you notice then, what I'll do then is the second half of the conversion packet that I gave you, it's assigned for tonight. It'll be due tomorrow night. Okay, so make sure then that you take a look at it. But I want to do one problem with you from that packet. Okay? And this is the problem here. This is number 14 in your in that packet. Okay, and so this problem does not look like the conversion problems that we've done up until this point. So this problem, remember I told you, with conversions, with the method that we just learned, okay, and that you've just applied to doing conversions, you can actually apply to working out algebra problems such as this one here. This algebra problem in the past, maybe some of you had issues with it, others may not, but a lot of folks have trouble with these types of algebra problems when they first learn it. I want to show you how using the method of conversions, the method we just learned, can also be applied to the problem like this here. So what I would like you to do, take about 5 minutes. Take about 5 minutes. It may not take you 5 minutes, but take about 5 minutes, work out this problem here in whatever way you feel appropriate. And then what I'm going to do is I'm going to apply the method of conversions to solving this problem here and show you how easily a problem like this can be dealt with using our methods of conversion. Okay, so go ahead and take 5 minutes to work out this problem. And then when you get back, we'll work this out together. Okay. Okay, let's go ahead and let's take a look at this problem here. Okay, so as a conversion, let me go ahead and backtrack here really quickly. As a conversion problem, if we're going to deal with this problem as a conversion problem, we have to answer 3 basic questions. Okay, what is the quantity that they ask us that they give us to start out with? Okay, what is the amount that they give us to start out with? What is the quantity that they want you to solve for? And then what are the conversion factors along the way? The issue here that we're going to have, if we're going to use the method of conversions, that you have to be able to answer that question in this context here. Okay, so we read this problem here. We're told that a chemistry class, you got 28 students. Each student has to be given 3 pens. The pens, eight pens in one package, $8.80 per package, and so forth. Okay, the question here then is, and let's go ahead and highlight this. What is the total cost? So that is, they're asking you about money. Okay, so they're asking you in the end, the end amount, whatever it is, the end amount has to be in units of dollars. Okay, units of dollars, that is the end unit, and we're calculating then for the amount of dollars. So remember, this isn't quite a measurement. This is not a measurement that we typically make in science, but we define, remember, we've defined then measurement as simply being a number and a unit. This is our unit, dollars, and we need to find that number there. So that's what we are calculating for. That's what we are asked to solve for. The question is, what is the starting quantity then? Okay, what is the starting quantity that they give you here? Okay, so understand this. This is where you do have to use a little bit of your analytical skills to get this done. But once you have this done, folks, it's just a matter of finding the conversion factors, and then you can solve this fairly straightforward. Okay, so what is it that we're starting out with here? Okay? Well, if you take a look at this here, they're asking you that what's the total cost to supply students, this class, with enough pens. And so actually the starting amount here, and the starting amount is not actually a measurement, but it is a quantity of students. That is 28 students. Okay? So that is what we are starting out with. We're starting out with a quantity of students. That means a number of students. And folks, quantities don't have to be masses. They don't have to be volumes. They can be just a number of counted objects. And we talked about that as well. Okay, so here we are starting out with 28 counted objects. And we want to find then the amount of money needed for those 28 students. Okay? Needed to do what? Needed to supply them with enough pens. Okay? All right, so that is what we have to do. The next question then is, what are the conversion factors? What are the relationships that we can take advantage of in order to get this done? Okay, so let's go ahead and and here's where, again, it's about analysis. Okay, so we know then that each student is given 3 pens. Okay, which means then what we're saying then is that every student, sorry, every student, which means one student, each student needs exactly 3 pens. There is the equivalence that we can take advantage of already. The problem tells us that. The problem tells us then that every student has to have exactly 3 pens. So that's the equivalence that we can use right there. Okay. Is there another one that you can find? Well, how about this one here? 8 pens, and again, with all these here, we're trying to find we're trying to track relationships here, okay? We are told that in the second one here that we have 8 pens that are exactly found in 1 package. Those 2 values are exactly equal. Remember, I told you, with these equivalences here, they are all arbitrary, even the ones that we accept in science that we state as fact. This is a fact. These are facts that we have arbitrarily assigned as a species. Okay? So that means that if we're gonna work out this problem, these are also arbitrary equalities that only apply to this particular problem. Only apply to this particular situation. This is not a universally accepted fact because this only applies to this particular problem. However, in this problem, those 2 values, these 2 here on either side of the equal sign, are equal as stated in the problem. And these 2 values here are also equal as stated in the problem. So again, we are applying the methods of conversion here to this specific problem here. Okay, and so with that said then, there is one last conversion factor that we can, one last relationship that we can take advantage of here, and it's this one right here. And so we are told then that for each package, okay, we have a cost of $1.88 for every 1 package. All right, so that's what we have right there. Now, do we have enough here to do this conversion? Okay. Well, let's remember, we have to ask ourselves, we start out with students, the unit here, and so here the unit's kind of an odd unit, but that's what we have, the number, the amount, the description here that of that number is students. So do we have students and do we have dollar? Do we have a dollar amount included in here in this so that we can do this conversion? Well, this first conversion factor here, folks, let's go ahead and take a look at this. This first relationship here, there's students, there's the unit students. And do we have dollars? And there it is, there's the dollar. So right now we have enough of the conversion, we have enough of these equivalences in order to get this conversion done. Right, so let's go ahead then and let's work out the problem. Let's do this together. Okay. Let's go ahead then and let's start out. Okay, so in this particular problem, we start out with this particular value, 28 students. So that's what we start out with. And since this is a whole number, we can put it over 1 to make it a fraction. Okay, because remember, conversions here are going to be fractional problems. Okay, so then we're going to draw our arrow and we're going to solve for this then, the dollar amounts, the amount of it will cost for the class. Okay, so the dollar amount per class, so that'll be over 1 as well. Okay, so we're trying to find then the total amount for the whole class. Okay, so if that's 28 students for one class, we're going to find the dollar amount for the whole class as well. Okay, all right. So with that said, then we need to get from students to dollar bills here. So which one of those? So hopefully you have it in front of you, folks. Which one of the conversion factors will we need initially? Well, we only had one conversion factor that had students in it. And that's the one that related, and I'll write this down here for you if you don't remember. We had the one, remember, that said then that we need 3 pens for every 1 student. Okay. And I'm sorry, let me go ahead and write this down. I apologize. We had second conversion factor is 1 pack of pens for 1 pack is equal to 8 pens in a pack. Okay. And then we finally had 1 pack is cost $1.88. Okay, all right. So this is the only conversion factor. This is the only equivalence here that has students in it. So we're going to plug it in here, and we're going to plug it in so that students is on the bottom and pens are on top. So we'll write down 3 pens on the top and 1 student on the bottom. Why is that? Because then we allow the unit student to cancel out right there. Okay, so we're on our way here. So we've used this conversion factor here already. So we've used this one. Don't use it again. Okay, so we've used it already. Go on to don't use it again. Okay, so let's go ahead and do the next one. Okay, so now we have pens here. Do we have a conversion factor that has the unit pens in it? And there it is. We have that one right there. So we'll go ahead and we'll plug that in with the 1 pack on top. Okay, and 8 pens on the bottom. Okay, why do we do it that way? So the unit pens here cancels out. Okay, and so hopefully, folks, you're recognizing all this. Okay, so we've used that conversion factor. Okay, and so finally, then we need to get from packs to dollar bills here to dollar bills here. And do we have a conversion factor that relates those 2 units? We do. Here's pack and there's dollar bills, and so we go ahead then we'll plug it in with 1 pack on the bottom, that unit on the bottom, and dollar bills, 188 on the top. That allows us to cancel out that unit there. Okay, we have finished and we've used this last conversion factor. The final check we're going to do then is, do we have the correct units in the right place? Well, in the end here, we want dollar bills in the numerator, that unit dollar in the numerator, and there it is. And everything else is canceled out. Okay. All right, very good. So with that said, then at this point you can punch in your numbers into your calculator, and hopefully you end up with then an answer that is $19.74 as your final answer. Okay. So here we've applied the method of conversions to a problem that is completely unrelated to conversions, measurements, okay, but it can be done. So the homework for tonight is going to ask you to practice this, and essentially I want you to practice this particular method of calculating conversions. Because if you can do this to problems that appear unrelated to measurements, you can absolutely apply it to measurements, especially when you're given the the equivalences here. If you're given that, and you are in science, you should be able to get that done. Okay. All right, so with that said, then get the homework done for tonight, folks. Practice it. I'll work out one more problem for you tomorrow from the homework that's similar to this, just to kind of highlight for you what we've done to this point. And so with that said, then that is it. We are done with the primer for conversions. And I know that this is been a bit, we devoted quite a bit of time to it, but I think it's well worth the time. Tomorrow, then what we're gonna do is we're gonna get back to the discussion of kinematics, and we're gonna talk about how we can graphically interpret displacement from a velocity time graph. Okay. All right, folks. So very good. Hopefully, I'll see some of you this afternoon. If not, please get the homework done, and I will see you tomorrow. Okay, have a good day.